This morning at 6:47 a.m., the International Space Station went completely dark. Not offline, not damaged, erased, as if 40...
The European Space Agency just released high-resolution images of Comet Atlas that break every rule of planetary science. We're seeing geometric patterns that shouldn't exist on natural objects, structures that look engineered, not random. And NASA, which captured even clearer images with their Mars orbiter, has gone completely silent. In 72 hours, this object reaches the Sun. And what happens next could change everything we thought we knew about our place in the universe. At 3:47 a.m. last Thursday, my phone buzzed with an encrypted file from a colleague at the European Space Agency. What I saw in those images made my hands shake so badly I nearly dropped my coffee. I've analyzed astronomical data for 30 years. I've seen countless comets, asteroids, and deep space objects. But nothing, absolutely nothing, prepared me for what's in these official photographs of Comet Atlas. Because what we're calling a comet might not be natural at all. I need to establish something before we go further. I've worked in astrophysics for 3 decades. I've reviewed data from Hubble, analyzed particle collision results from CERN, and consulted on planetary defense programs tracking near-Earth objects. I know what rocks look like in space. I know how ice behaves under solar radiation. I understand cometary physics inside and out. The European Space Agency's Mars Express orbiter observed Comet Atlas on October 3rd from just under 30 million kilometers away. At that distance, their high-resolution stereo camera can distinguish features as small as 50 meters across. That's like reading a license plate from halfway to the moon. The imaging window lasted 12 hours, capturing multiple angles as Atlas moved through its trajectory. And what those instruments recorded challenges 40 years of my professional understanding. Because this object isn't behaving like any comet I've ever studied. Let's start with what we expect to see. Comets are dirty snowballs, right? Chunks of ice and rock left over from solar system formation. When we photograph them up close, they look like potatoes. Irregular, lumpy, covered in craters from billions of years of impacts. Halley's Comet looks like a peanut. Comet Tempel 1 resembles a battered football. These shapes make sense because gravity pulls material together randomly, and collisions chip away at surfaces over time. Atlas doesn't look like this. The primary nucleus measures approximately 4.7 kilometers along its longest axis. But instead of the chaotic surface we see on every other comet, Atlas displays smooth sections. Areas where the terrain looks almost polished. The forward-facing hemisphere, the part cutting through space first, shows remarkably uniform curvature. No major impact craters, no boulder fields, no cliff faces or irregular terrain. When I first saw the imaging data, I thought maybe we were looking at fresh ice that hadn't been weathered yet. But the spectroscopic readings don't match water ice. They don't match rock either. The surface is reflecting light in ways that don't fit our material databases. And then there are the patterns. Covering roughly 40% of the visible surface are geometric structures arranged in a grid. Hexagons. Each cell measures about 200 meters across. They're not perfect. There's some variation. But the consistency is disturbing. Imagine looking at a honeycomb. Except this honeycomb is carved into an object hurtling through space at 43,000 kilometers per hour. Natural processes don't create hexagons this regularly. Yes, basalt columns on Earth form hexagonal patterns when lava cools and contracts. But those form in gravity, with specific cooling rates. In geological environments, nothing like deep space. We're talking about an object that's been in the freezing void for potentially millions of years. A team at the Max Planck Institute ran pattern recognition software on the images. This software analyzes whether structures form through random natural processes or show signs of organization. It measures symmetry, spacing, consistency, and deviation from expected geological patterns. When they processed the Atlas hexagons, the algorithm flagged them as anomalous. The statistical probability of these patterns forming naturally came back at less than 1 in 8 million. Now, I'm not saying this proves artificial origin. Statistical anomalies happen. Maybe there's some exotic physics we don't understand yet, some process involving magnetic fields or crystallization in extreme cold that creates regular patterns. But if that's the case, we need to rewrite our textbooks, because right now we have no natural explanation for what we're seeing. Then there are the openings, 7 circular features arranged along the equatorial band of the nucleus. Each one measures between 80 and 120 meters in diameter. The edges are smooth, almost machined, and they're spaced at remarkably consistent intervals, roughly 600 meters apart. These aren't surface cracks or collapsed pits. When sunlight hits Atlas at certain angles, shadows fall into these apertures, and we can calculate depth from shadow length. The measurements suggest these openings extend deep into the interior, possibly hundreds of meters down, maybe connecting to internal structures we can't see from the surface. I consulted a planetary geologist who specializes in cave systems on Mars and lava tubes on the Moon. I showed her the images without telling her what object she was looking at. Her assessment was immediate. These don't match any natural formation I've studied. The circular geometry is too precise. Natural collapse pits are irregular. Lava tubes have uneven openings. These look like ports or access tunnels. When I told her this was a comet, she went quiet for a long time. Then she asked if I was joking. The trailing hemisphere shows something even stranger. Extending from the main body is a structure approximately 300 meters long and 110 meters in diameter. It's cylindrical, not irregular, not jagged, cylindrical. Think about what that means. Natural objects in space don't grow cylinders. Asteroids are potato-shaped because gravity pulls material into irregular lumps. Tidal forces stretch objects into ellipsoids. Rotation can flatten poles and bulge equators. But cylinders? That geometry doesn't happen naturally in space. This protrusion isn't a fragment that broke away and is drifting nearby. It's attached to the nucleus, solid, structural, and it tapers at the end into a rounded cap, almost like an engineered joint or connection point. I sent this image to an aerospace structural engineer without context. He asked if this was a fuel tank from the International Space Station or a component from a satellite. When I explained it was a natural object from deep space, he laughed. Then he realized I wasn't laughing back. His exact words, "Nature doesn't machine parts." I ran an experiment. I compiled the clearest images of Atlas and sent them to 5 different specialists across different fields: a structural engineer, a geologist, an architect who designs large-scale infrastructure, a materials scientist, a planetary formation expert. I gave them no context, no labels. Just asked them to describe what they were looking at. 4 out of 5 used the word artificial in their analysis. The structural engineer identified what he called load-bearing components. The architect noted modular design principles. The materials scientist pointed out surface treatments inconsistent with natural weathering. Only the planetary formation expert hesitated. But even she admitted the features didn't match any accretion or geological process in her database. These are credentialed professionals analyzing raw data. And independently, without coordination, they reached the same unsettling conclusion. But the chemical composition might be the strangest part of all. Every comet we've studied up close is dominated by water ice. Halley's Comet, 78% water. Tempel 1, 82% water. Churyumov-Gerasimenko, 80% water. Water drives cometary activity. When sunlight heats the surface, water ice turns to vapor, carrying dust away and creating that classic tail pointing away from the sun. Atlas is 96% carbon dioxide. Almost no water at all. That shouldn't be possible. Water and CO2 condense under similar conditions in stellar nebulas. They should exist in comparable ratios. To get an object that's almost pure carbon dioxide requires formation conditions we've never observed. Or it requires something else, something selecting specific materials for specific purposes. The coma, that cloud of gas surrounding the nucleus, behaves wrong too. It's symmetrical, spreading evenly in all directions instead of streaming away from solar radiation like physics demands. It's as if the outgassing isn't driven by temperature, but by something internal, something controlled. And then there's what happened when NASA went silent. NASA's Mars Reconnaissance Orbiter observed Atlas the same day as SETI. Their camera resolves features down to 30 centimeters. 30 centimeters. They could see individual boulders, surface textures, and structural details invisible in ESA's images. 3 weeks later, NASA has released nothing. No images, no data. Just a brief statement confirming the observation occurred. ESA's images show surface reflectivity approaching 30% in visible wavelengths. Most asteroids reflect 5 to 15%. Ice bodies may be 20 to 25%. 30% is what you get from polished metal or specialized optical coatings. The spectral signature doesn't match any natural mineral or ice formation in our databases. When I compared Atlas to every comet we've photographed, Halley, Borrelly, Wild 2, Hartley 2, the difference is stark. Those objects look like rubble piles, random, chaotic, natural. Atlas looks organized, structured, purposeful. In 48 hours, Atlas reaches perihelion, its closest approach to the Sun. Every telescope on Earth will be watching. If it fragments like a normal comet under thermal stress, maybe we've just witnessed exotic physics we don't understand yet. If it survives intact, maintaining those geometric patterns and cylindrical structures, then we need to ask harder questions. And if it changes trajectory using the Sun's gravity in ways that suggest navigation rather than orbital mechanics, NASA knows something. Their silence isn't accidental. The images they captured show